Alright, this is your 7.1 notes, systems of linear equations in 3 variables. So back in chapter 2 we did systems of 2 variables, meaning we had just an x and a y, and now we've got 3 variables, x, y, and z. But the goal is the same as it was before. We want to come up with what x, y, and z need to be, that when I plug them into all 3 of these equations at the same time, that's what this little bracket right here means, that all of them have to be satisfied at the same time. That instead of ordered pair, that ordered triple works in all 3 equations. So the way we're going to do it, it may be a review to you, but the way we typically do this is just using what we call elimination and back substitution. So we take our 3, what I call a 3x3 system, meaning 3 equations, 3 variables, and we reduce it down to what we were using in, or what we did do in chapter 2, which is what I call a 2x2 system, 2 equations and 2 variables. And the way we do that is use this 3-step process. We pick 2 equations, eliminate a variable via addition, okay, and then once we've done that, we pick another pair, a different pair of equations, but we make sure to eliminate the exact same variable, okay. I'm going to highlight that to make sure that you understand it's got to be the exact same variable that you eliminated in part A. And then once you've done that, you've got a 2x2 system. You've eliminated one of the 3 variables in part A, so that's 2 variables. You eliminate the same variable in the second pair, so that's going to be from 3 down to 2. So you're going to have a 2x2 system. Alright, and then you solve that 2x2 system if possible, and then I didn't write it in here, but you back substitute. We'll talk about what that is when we get there. So we back substitute to find the other 2 variables. Alright, so let's just go through it so you get an idea how it works. Alright, so this system, we have x plus y plus z equals 2, x minus y minus z equals 0. Alright, because of that sign change that I have between these two, a plus y, a minus y, a plus z, a minus z, I'm going to add, for part A, I'm going to add these 2 equations together. Okay? Via addition means add them together if you have opposite signs. So when I add them together, I get x plus x is 2x. Alright, and then positive y minus y cancels. Positive z minus z cancels. Okay? And I only have x. That's the only variable left. And then 2 plus 0 equals 2. So I have 2x is equal to 2. Alright, now I can go ahead and solve that. Divide both sides by 2, divide both sides by 2, and I get x equals 1. Alright, so far we know that x is equal to 1. Alright, now that's step A done. Alright, I picked 2 equations, I eliminated a variable. I actually ended up eliminating 2. Alright, now I'm going to pick, for the second part, I'm going to pick equation 1 and equation 3. Now why am I doing that? Because this has got a positive x, a positive y, a positive z, and this one's got a negative z. So that z and that z will cancel. Alright, so over here I'm going to write x plus y plus z equals 2, and x plus y minus z equals 4. Right, now when I add these together, this z and this z cancel, and we get 2x plus 2y is equal to 4 and 2 adds to 6. Alright, now this has 2 variables in it, 2x and 2y, but over here we were told that x was equal to 1, so that means I can replace this x right here with 1 and say 2 times 1 plus 2y equals 6. Alright, well, what's 2 times 1? 2 times 1 is 2. Subtract 2 from both sides, and I get 2y is equal to 4. So that means that y is 2. Alright, now I know what x is, I know what y is. All I have to do is go in and figure out what z is. So I can go into any of the three equations. This is what the back substitution part is. I can go back into any of the three equations and plug in 1 for x from this down here. I can plug in 2 for y from this over here and figure out what z is in any of the equations. So I'm going to go into the bottom equation here, and I'm going to say, alright, x is 1 plus y is 2 minus z is equal to 4. Alright, 1 plus 2 is 3 minus z equals 4. Subtract 3 from both sides. Alright, I get negative z is equal to 4 minus 3 is 1. I don't want negative z, I want positive z, so I divide both sides by negative, and I get z equals negative 1. Alright, so my ordered triple, again, it's an ordered triple, not an ordered pair, but my ordered triple is x equals 1, y equals 2, and z equals negative 1. Alright, now your last step, it's an optional step, just throw it in there and check to make sure that this works. Okay, now you can use your calculator to kind of help you with this. You don't have to do it this way. You can just, plug them in individually. But notice you have this store button on your calculator. I can say, all right, let's make 1. I'm going to store that as x, because this is in the x position. All right, it goes alphabetically, just like it did when it was a pair, x, y, z. All right, so I'm going to say 2. I'm going to store that as, I'm going to press alpha, and here's 1 above that is y in alpha mode. All right, and then I'm going to store negative 1, store that as z. All right, and then I just write my 3 equations and see if it works. All right, what is, I'm going to press second alpha lock. What is x plus y, plus y plus z? 2. Alright, so the top equation works. Alright, I'm going to hit second enter, brings back the last thing I did, and now I'm going to change the minus, or the 2 pluses to minuses. So there's a minus, there's a minus, hit enter, 0, that works, and then change the first minus to a plus, hit enter, 4. Okay, so the 1, 2, negative 1 that we got as our solution does work. Okay, so we know that that is a valid solution. So that's the store feature. You can use that to check these. Just remember to go into alpha mode. The store, you can also use that button as X, but this is like the universal X button, but they'll both do the same thing. Alright, jumping down here, this is another, we're going to do the exact same problem, but this is another means to do it. They call it the left to right elimination method. I call it the triangular upper triangle method. It doesn't really matter what you call it, just as long as you understand this procedure. So what we're basically going to do, the reason why we call it the upper triangle method, is we're going to eliminate these x's down below this top x, and then we're going to eliminate this bottom y right here, but leave these top two. So we'll have this like diagonal pattern here, everything from here and up will be there, but these are going to end up being zeros. Alright, so let me show you how this works. Now I'll go back and show you what each one of these steps means. So we got x plus y plus z up top equals to x minus y minus z equals 0. Alright, and then x plus y minus z equals 4. Alright, so what this is telling us to do is we can move the rows around, swap the rows around to make the coefficient of x in this first equation a 1. Okay, so this one already is a 1, but if this had been a 2x and this had been a 1x, we could switch their positions. Okay, it doesn't matter what order the equations are given to you. So we can always move them around if we need to. If none of them had been 1, like if this had been a 2x, a 3x, and a 5x or something, we could divide the top row by 2 till we get a 1. Okay, that's what this first thing's telling us. But basically the first step is get a 1 right here, a 1x. Right? Well, we've already got one, so we don't need to do that. Alright, so since we've got step 1 done, we're going to jump into step 2. Add multiple of the first equation to each of the other 2 equations so that the coefficients of x in those become 0. So what this means is I have to take this 1x and multiply by something to add to this 1x, so when I add them together I get a 0. Alright, so this is 1x plus something times 1x equals 0. So what I'm going to need to do is multiply the top row by -1 and add to the second row. Okay. Alright, and the way that we write that is multiplying the top row by -1, add the second row, we write -1 times R1 plus R2. Okay, and we're literally taking everything in the first row, R1, this is R1, and we're multiplying that by -1 and then adding it to R2. So -1 times 1x is -x. -1 times 1y is -y. And -1 times z is -z. Alright, -1 times 2 equals -2. Alright, so this right here that I'm highlighting is -1 times R1. Okay, so this is -1 times R1. Alright, now all I'm going to do is just rewrite R2 the way it was. X minus y minus z equals 0. Okay, now adding these two together, if I take those two equations and I add them together, the -x and the positive x cancel. So that gives me a 0. -y minus another y is a -2y. -z minus another z is -2z. Alright, and then -2 minus 0 is still just -2. Alright, now this bottom row right here, alright, I'm not going to include the 0 since 0 doesn't add anything to this. But this is this whole thing. Alright, it's R1 times -1 plus R2. This whole thing is. Now what we do with that is we replace the second row with it. Okay, so this row is going to be replaced with this. Alright, so I got an x plus y plus z. That equals 2 still. Alright, and then a x minus y minus z equals 0 is replaced with negative 2y minus 2z is equal to negative 2. Alright, and then we just keep the bottom row as it was. X plus y minus z equals 4. Alright, now we're going to do the exact same thing. We go back up and look at our steps. Alright, multiply or divide both sides of the second equation by a number that, do that same thing to the second and the third equations to make them become 0. So the same thing that we just did, multiply by negative 1 and add to the second to get rid of this x. We're going to do the exact same thing, except we're going to do it to the third row to get rid of this x. Alright, so here, multiply by negative 1 and add to third row. Alright, again in notation it would be negative 1 times row 1 plus row 3. Okay, so I'm going to multiply this row up here. Alright, again, negative 1 times r1, just like it was before, is negative x minus y minus z equals negative 2. And then r3 is x plus y minus z equals 4. Alright, and then if I add these two together, these cancel, these cancel. The only thing I'm left with is a negative 2z equals, adding these together gives me a positive 2. Alright, and once again, just like I did before, I'm going to take this that we just got here. Again, this is negative 1 times r1 plus r3. I'm going to take that and I'm going to replace it with the old r3. Alright, I'm going to replace that in the equation. Alright, now what's that going to give me? It gives me x plus y plus z equals 2 negative 2y minus 2z equals negative 2. Alright, and then this is all we have left of the third equation. So negative 2z equals, positive 2. Alright, so there's our system after this step. Alright, that's all step 1. Or sorry, step 2. Step 3, multiply or divide both sides of the second equation by a number that makes the coefficient of y in the second equation equal to 1. So if we come down here to what we have left, which is this, what do I need to divide this equation by to get a 1 right here? I need to divide this middle equation. We're going to divide by a negative 2. So divide by negative 2, divide by negative 2, divide by negative 2. Alright, I've got x plus y plus z equals 2. So this is still the exact same first equation. I'm just rewriting this first equation here. Alright, this is now positive 1y, positive 1z, or just plus z, equals negative 2 divided by negative 2 is 1. Alright, and again, just pull this one down. I'm just going to pull this third equation down just like I had before. So minus z equals 2. Alright, now notice what the next step would be after that. add a multiple of the new second equation to the new third equation so that the coefficient of y in the newest third equation becomes 0. Meaning 0 out below this y. Well, it's already zeroed out. It canceled out in the last step. So we're actually done with this step. Alright, so that one's done as well. Now, in step 5, we multiply or divide both sides of the third equation by a number that makes the coefficient of z in the third equation equal to 1. Alright, so we're working with just the third equation now. We want a positive z. So instead of a negative z, we want a positive z. So we're going to divide both sides of this thing. I'm sorry, I lost my negative 2z. We're going to multiply both sides of this thing, or divide by a negative 2. Alright, so coming over here, that's going to give me x plus y plus z is equal to 2. Y plus z is equal to 1. And now this newest one, negative 2z divided by negative 2 is just z, equals 2 divided by negative 2 is negative 1. Alright, so now at this point we know what z is. Z is negative 1. And now we back substitute. That means that's negative 1. So we get y minus 1 equals 1. Alright, so add 1 to both sides, we get y equals 2. Alright, so now we know y is equal to 2. So up here in this equation, we know this is 2, and from down here at the bottom, we know this is negative 1. So we have the equation x plus 2 minus 1 equals 2. Alright, 2 minus 1 is 1, so x plus 1 equals 2. Subtract 1 from both sides, we get x equals 1. Alright, now a good, very good idea would be to do like we did before and use your calculator just as we did previously and make sure that the original thing works. Now we've already seen that it does work. We got the same x, y, and z triple this time as we did last time, so we know that it's right, but always take the time to go back and check, because again, there's so many steps to this. There's a lot of places where things could go wrong. Now personally, me, if I'm doing a problem like this, I'm doing the first method I did. I mean, obviously look at it, it was just, you know, not very difficult, a couple of steps, and we had that thing solved. Where with this triangular method, this upper triangle method, it's a little bit more involved to get it into that certain form. But you know, if you like it, then use it, go for it. Alright, let me move this to give myself some room. Alright, again with these, I don't care which way you go about doing it. I'm going to do it the first method. So I've got a positive x, a positive x, a positive 2x, a 2y, a negative y, a positive y. Alright, I'm going to eliminate, in my opinion, it would be easiest to eliminate either y or z here, just because of the sign changes. We won't have to multiply anything by negatives. So I'm going to use these two equations right here. Alright, and I'm going to multiply the top equation by 2 to get a 2z and a negative 2z. Alright, so I'm going to multiply top by 2. Now we can do that. I mean, you're just multiplying both sides of an equation by the same number. So I get a 2x, a 4y plus 2z equals 4. Right, and then I'm going to leave the second equation how it was. So x minus y minus 2z equals negative 4. Now notice these have opposite signs, so when I add them together, those two things cancel, and I'm left with a 3x, a 3y, and then no more z's, and then these combine to 0. Okay, now I picked these two, so I can't pick these two again. I can pick either these two, or I can pick 1 and 3, right? But I can't use 1 and 2 anymore. So this time I'm going to pick equation 1 and equation 3, just because it's a sign change and eliminate z. Remember, I got to eliminate the exact same one. So this time I'm going to take x plus 2y plus z equals 2. That's the top equation, just rewritten. And I'm going to take 2x plus y minus z equals 4. Okay, and I'm going to combine them together. Alright, now because of the sign change, these are already going to eliminate. We want to eliminate the same variable we did here, and we eliminated z here, so we're eliminating z again. We're going to get 3x plus, this time we get a 3y, and 2 and 4 adds up to 6. Now, you may see the problem now, but if not, remember what we're doing here is we're trying to go from 3 variables down to 2 variables, and that's what we've done here. We've got this mini system. What I have in the yellow is its own system of equations that have to be true. But again, the problem is we've got 3x plus 3y equals 0, but 3x plus 3y also has to equal 6 according to this equation. So if you can't see it there, you're going to see it. Remember how we solved this. This is the 2 by 2 system. So if we're going to solve this by elimination, I'm going to multiply one or both rows by something to get a sign change. So I'm going to multiply this one by a -1. That gives me a -3x minus 3y equals 0. Right? 0 times -1 is still 0. And then just this same equation written again. And now when I combine these together, the x's cancel, but the y's also cancel, and I'm left with 0 on the left, but 0 plus 6 is equal to 6. Now, what you have to be comfortable with, you've got to get yourself where you're confident that you know what you're doing, that when something like this should happen, and it will happen, but you have to be confident that you haven't done anything wrong, and allow those variables to cancel away. Okay? If the algebra that you do causes cancellation of all the variables that remain, then just let it be. Alright? It happens sometimes. Now what we're left with here is a false statement. Okay? 0 equals 6 is not true. Okay? Now what this means is, if our original system is to have a solution, if this system right here is to have a solution, then 0 would have to be equal to 6. Alright? Is 0 equal to 6? No. Alright? Because our work made us arrive at something that's not true, then the system has no solution. Alright? This is what we call an inconsistent system. So they'll ask you that in some of your homework problems, to identify a system as inconsistent or dependent or independent. This is the first special type. This is inconsistent. If there is a unique solution like there was to the last one, that's called a dependent system. Right? The last type we're going to see, the next one, is independent, meaning there's infinitely many solutions. So this last one is an example of that. Alright, again, in this case I'm going to use, I'm going to eliminate x here because of the sign change. I could also just as easily do y, but I'm going to do x here. So I'm going to start off by combining these two equations together, first and second, and I'm just going to add them together. Alright, -x plus y plus 2z, if I add that, or equals to 0, if I add that to the equation x plus 2y plus z equals 6. If I add those two together, I get the equation. Those cancel. 3y plus 3z equals positive 6. Okay? Now, after I've done that, I'm going to multiply. I'm going to use number 2 and number 3. I'm going to multiply the middle equation by 2. Alright, again, we're allowed to do that because we're just multiplying both sides of an equation by the same number. They were equal to begin with. They're going to be equal when we double both sides. I'm going to distribute that 2 through. That gives me 2x plus 4y plus 2z equals 12. Alright, and now I'm going to combine that with the third equation, negative 2x minus y plus z equals negative 6, and notice that 2x and the minus 2x cancel. Alright, and then that leaves me with a, just like before, a 3y, a 3z, and that equals 6 again. Okay, now if you don't, again, if you notice it, then you can stop right now. If not, remember your goal is to get a new system with 2 variables, and we've got that. So this 3y plus 3z equals 6. This is coming from this one right here. And then I've got another one identical to that right here. 3y plus 3z equals 6. And just like before, if I multiply both sides of the equation by negative 1, I get a 3y plus 3z equals 6. A negative 3y minus 3z equals negative 6. Alright, now everything cancels. The y's cancel, the z's cancel, leaving me with 0. And then 6 minus 6 is also 0. So similar to the last time, and all the variables canceled. But this time we have the equation 0 equals 0, which is true. So it's a little bit different last time. Last time we got 0 equals 6, which was not true. But now 0 does equal 0. That's true. So we have, this is what we call a dependent system. Alright, and what we do here to come up with a dependent system to give our answer is we allow z to be anything. Okay, so z can be anything. Alright, and then the dependency, x and y depend on what z is. And usually you use the last letter. Like if you use x, y, z, z will be what gets to be anything. If you use a, b, c, c is usually what gets to be anything. But it doesn't really matter. Any of them can be the independent variable, and then the other two depend on that variable. Alright, and then what we basically do is just solve the other equations for z. Okay, so this equation here that we had, I'm going to solve that for z, and that's going to give me how y is related to z. So I've got 3y plus 3z is equal to 6. If I pull out this common 3 that's common to both, I get 3 times y plus z equals 6. Divide away that 3. Alright, that gives me that y plus z is equal to 2. Alright, and now I can isolate y and have y in terms of z. So y is equal to 2 minus z. Alright, so now so far we've got z can be anything, y has to be 2 minus z, right? And then just take both of these things, substitute them back into any equation, and figure out how x is related to z. Alright, so I've got, let me switch that around. I got x plus y plus 2z equals 0. Alright, z I'm going to leave it how it is. Y is equal to 2 minus z, so x plus 2 minus z is what I'm going to replace y with, because I'm trying to get just x and z together to see how they're related. Alright, so this minus z and this plus 2z combines to just a plus z. Alright, and remember, I'm trying to isolate x, so I'm going to add it to both sides. Alright, so on this side, x's cancel. I've got x equals, this x right here equals z plus 2. Alright, so my solution to this system are any ordered pairs of the form z plus 2, that's x, 2 minus z, that's y, and then z can be whatever. Right, so this can be anything. This is whatever that number is subtracted from 2, and then this is whatever this number is with 2 added to it. Alright, so if z were 4, 2 minus 4 is negative 2, 4 plus 2 is 6. Alright, if z were 0, then that would be 0, 2 minus 0 is 2, 0 plus 2 is 2. Okay, so it all depends on what z is, what x and y are going to be.